Okay, for example, we take a question and we carry our topic that was we just took for critical angle and total internal refraction. Okay, reflection. So question, let us see one question, application question. Calculate the critical angle for glass air surface, for glass air surface. Okay, if a ray of light which is incident in air on the glass surface is deviated, on the air on the glass surface is deviated through 15° when angle of incidence is 45°. Okay, calculate the critical angle for glass air surface if a ray of light which is incident in the air on the glass surface is deviated through 15° when the angle of incidence is this thing. So
what is the value of sin?
So this is where CBSE comes into practice. So we think that it will happen its own. If you really see how the question goes, calculate the critical angle for glass air surface. So here it is air, right? And here it is glass. Let us try to understand this question. Okay. If ray of light which is incident in the air, so this is an incidence ray, yes or no?
Yes.
Incidence ray. Okay, on the glass surface is deviated through 15°. That means this AB would have gone to actually BC, yes, but it is deviated to BD. So it is this angle which is actually given to you. Yes. So you really don't need 15° value. So if you read it carefully, you will be really getting a lot of surprises in your examination because it will be truly an application oriented question. So actually your R is 30° and not 15°, remember, and I is 45°. So how do you calculate now? What will be your mu? Mu will be sin I upon sin R, okay, which is sin 45 upon sin 30°. Got it? So what is my mu? Mu is √2. Mu is √2 because this is 1 upon √2 upon 1 upon 2, which is 2 upon √2, which is simply √2. Got it? Now what will be my sin IC? Sin IC, we have just seen the relation. Mu was 1 upon sin IC. Do you remember? 1 upon sin IC is mu. Therefore sin IC is 1 upon mu. So 1 upon mu means 1 upon root 2. So if sin IC is 1 upon root 2, what is your IC? IC is simply 45 degree. That's your answer. So do you know now difference between CBSE and JEE? But you have to be methodical in your approach. That's the only thing that I can tell you. If you are doing step by step, you have nothing to lose. If you read your question carefully, you have nothing to lose. But if you don't do these two things, you have everything to lose. All right. Let's try to do one more question. The refractive index of water is 4/3. Obtain the value of semi-vertical angle of the cone within which the entire the entire outside view would be confined for a fish underwater. For a fish underwater. Draw an appropriate ray diagram. Draw an appropriate ray diagram. This is the question. So can you envision your problem? Your problem would look like this. Let's say this is the vessel. And here is your location of the fish. Okay. So how the ray would go? It will go like this. This would be your enhanced possible vision. Okay. And this, if you see in the center, semi-vertical angle is, let us say this is whole angle is theta. Okay. Okay. Yes or no? And if you really see, suppose this is your water surface, so and if this ray goes like this, then to ensure that which is your view, the view actually would be closed here only if this ray goes like this. इंटरनल रिफ्लेक्शन के लिए 90 डिग्री होना चाहिए उसका, right? So that means, and this would be my obviously IC when it is 90 degree. If you see, this is 90 degree and this also would be 90 degree. Yes. So if you see, this is your IC. So what will be mu? Mu will be 1 upon sine IC. Okay. और we can say, because 4/3 हमको दिया हुआ है, it is 1 upon sine IC, and sine IC would be 3 upon 4, which is 0.75 actually. Yes or no?
Yes.
So IC is actually, if you see, theta by 2, frankly. Theta full tha, so IC would be half.
Yeah.
So theta by 2, IC would be theta by 2, which is actually sine inverse 0.75. For CBSC, you can leave it like that. For ICSC, you use your calculator and give your answer, which will be 48.6 degree. Okay. So this is how you can tackle this entire thing using applications also. Now at home, you can do few questions on this total internal reflection, also on your displacement. Okay, lateral, yeah, and an optical fiber, few application. So this topic will be ready. Okay.